Good afternoon, everyone, and welcome to Day 8 of Singapore Geospatial Week Plus. We are pleased to have the Build and Infrastructure panel today, and without further ado, let me pass it on to the moderator, Saibal Das-Chowdhury from Urbanetic. He's the co-founder and CEO. Over to you, Saibal. Hello, Saibal.
Oh, sorry, I was muted. So again, welcome to the Geospatial Week, and I'm delighted to be presenting or moderating the session on innovation, on geospatial innovation, and today we will covering the topic of the geospatial innovation for the built environment, from survey to the GeoBIM to digital twins. What we will do, just to back down to the context, that the digitalization process has already started across all the industries, and the AEC industry was no exception. And what the pandemic has done is it has accelerated greatly, maybe 3 to 4 times on the whole process. So we talk about today that whether we will, with the specialists and the panelists, that whether there will be further acceleration, or there will be some areas there will be a little bit of slowdown, and some areas there will be acceleration. So without further ado, I introduce, I will ask my speakers to introduce themselves and speak about around 8 minutes about the innovation in their area and other areas for the next 3 to 5 years. To start with, I'd like to start with Dr. Victor Khoo from SLA.
Thank you, Saibal. Good afternoon, all. Happy to be here today to participate in this panel discussion. I do a quick introduction of myself. I am working in the Singapore Land Authority, leading a division known as the Survey and Geomatics division. I've been working in this area for more than 18 years already. Focusing in the area of positioning, geodesy, geomatics, and geospatial information management. And over the years, I've led several digital transformation projects in Singapore. I've been working on the national GNSS positioning infrastructure. We call it SIREN in Singapore. I've been working on the area of national spatial data infrastructure, national 3D mapping program, as well as the digitalization of the cadastral survey system in Singapore. So today, I think the topic about digital transformation in AEC, there are 2 terms that comes to my mind. I'm going to speak from the perspective of agencies in Singapore. What have we been doing in this area, and we'll open up for discussion after this. So in Singapore, the digital transformation in AEC started way back in 2010. A few agencies, I think led by BCA, started the BIM roadmap. So BIM, BIM is the format, is the standard that we believe that is the core for the digitalization in AEC. So 2010, there's a BIM roadmap. 2015, we started something called Virtual Design and Construction Roadmap. So these are the initiative by BCA and a few agencies trying to transform the industry, to adopt more digital technology. And lately, in 2018, a new initiative started, known as the Integrated Digital Delivery Initiative. This is a more encompassing initiative, looking into the use of digital technology to integrate work processes and connect stakeholders working on the same project throughout the whole life cycle of a project, from from design, planning, to construction, to fabrication, to assembly, and even to facility management, or the whole life cycle. So SLA, HDB, JTC, the different agencies play different role here. And the IDD steering committee was formed, comprises of people from the agencies as well as from the private sector, together to look into this area, to promote, to set target, to introduce strategy, to drive implementation in this area. And one key word here, key area that we are looking at is really the integration between Geo and BIM, because BIM would be the format, the main source, digital source of information that is adopted by the AEC industry, and there's this element of Geo that is needed, and integration of Geo BIM become an important discussion topic. Some call GeoBIM, initiative of GeoBIM in Europe. You hear that there is a lot of research in this area, looking at workflow, looking at the benefit of GeoBIM, looking at several areas. In Australia also the same thing. So in Singapore's context, a few agencies again come together, looking at the different stages of the AEC, from planning and design. How would the GeoBIM comes together? So in this case, we are talking about topographic map in a digital form, the digital twin. How would this information, the 3D city model, how would this information practically used by the private sector as well as the government in terms of planning a city, design for smaller sites? How would this information shared and can benefit the practical implementation of this area? And then after that, we also look into the regulatory submission. In Europe, they call it building permission. For any construction, you need this from the authority. And how would the Geo and BIM come together in terms of automatic checking of building requirement, digital workflow, looking at the land ownership, legal restriction, modeling? So how would the digital twin can be used in the noise modeling, in all kind of modeling for the legal restriction? So this is another important area where the Geo and BIM comes together. In the process of construction, when you start to construct, start to build, again, where does the Geo comes in? Automation. In this case, we are talking about using technology like GNSS technology, some sensors to automate machines in the construction site, like piling machine, like crane, and combine BIM data, to automate some of these processes to help the industry move out from foreign labor, for example. So this is another area where Geo comes in to work with the BIM and to contribute towards AEC. After you start to build, there is this requirement for progress monitoring or progress checking, throughout the whole life cycle of the construction. And again, technology like laser scanning, UAV are main character here. They are being used, being introduced into the sector to digitalize, or again to digital transform the sector. At the end of the construction, you have the survey of ownership, survey of the boundary. This again, from the SLA's perspective, we have already introduced digital workflow for this whole process. Last but not least, after the construction, the delivery of the infrastructure as well as facility management. Again, the agencies and the sectors are looking at various ways using the digital twin, using the BIM models that has been created to continuously improve the maintenance of the building, and this is really the area that very little attention is being put in as of now, because it's at tail end of the whole workflow. But I think all these attentions are required, and we are looking at all this the whole workflow one by one, and looking at how does the geo and the BIM comes together, integrated to improve the whole workflow. So I'll pass the floor back to Saibal. Thank you.
Thank you, Dr. Khoo. That was fantastic. I think especially the Geo BIM should draw the attention of many audience here, and also hopefully we will elaborate it during the discussion. I would like now ask John Whitehead, Mr. John Whitehead, to introduce himself and speak about 8 minutes. Thank you, John.
Thank you. I'm going to share my screen. Are you guys able to see? You guys are able to see my screen?
Yes.
Okay, sorry. Yeah, so I mean, first, just introduce myself. I'm John Whitehead from Trimble. I decided to add this photo of a previous life. I'm not a surveyor by training, but I have always worked with geospatial technology and projects, and this is an old land titling project I took part in China, evaluating technology long ago. So it's always been close to my heart, even though I'm an economist by training. And I wanted to talk today about the dynamic landscape for the evolving surveyor, or geospatial professional, as the lines are getting blurry. What's the new normal given COVID and all that? Acceleration in the industry that Saibal talked about. What kind of new tech is driving that or assisting that, and then what new thinking we need as an industry to really capitalize on that. And within the context of what's happening in the building and infrastructure space. So Trimble, we've always been active in this space in our 40 plus year history. We started out in positioning. We're now very much evolved into focusing on integrated work processes. And so that includes technologies that are used in the field to capture data, process data then, and obviously share it and optimize work processes. And so geared very much around transforming the way the world works. That's our company model, but the idea of productivity and efficiency being sort of center to everything that we do in a number of sectors, but obviously building infrastructure, a key one. The idea that we had talked about as a panel is to kind of look at the industry from its components on a project basis, starting with planning all the way through to operation and maintenance of something that is constructed. And, you know, prior to getting into that, I just want to, you know, my take on what's going on in the AEC sector is there a big adjustment that's underway due to COVID? I don't think it's primarily due to COVID, but COVID has accelerated the process that was going to come anyway. And that is very much around digitalization and what's needed to kind of take the industry into a new phase where technology adoption and leveraging technology is heightening productivity on any given project or on the industry as a whole. But some of the changes that are coming, I think there's higher expectations from project owners around productivity, yes, but there remains a misunderstanding or maybe not misunderstanding, but a limited understanding of how geospatial data works in that context and what the pitfalls are of not leveraging geospatial data on a project. So if you have a data poor project, I would call it, what the pitfalls are there and what the impact might be. So there's very much a concept of, from an economic standpoint, looking at what the opportunity cost of using technology, the latest technology on a project versus not is. And all of that in the context of the building and infrastructure space is also, there's a pressure on service providers. And even if you're not a service provider contracting into a project, you may be a prime contractor or even a government body that's intended to focus. You may be working in a group that's intended to focus on how geospatial information can help drive more efficiency and productivity into a given project. And so there's this pressure on getting better at what we do and leveraging technology. So compared to sort of the traditional services marketplace where, you know, you would kind of react as a company or as a group in a larger company, you would react to a demand coming in from the market. The new normal is kind of requiring us to change our attitude about what our role should be in this space. And I've broken it down here at the project level, starting at the strategy all the way through concept plan, design, you know, all the way through to operate and maintain. And in the traditional process, the expenditure, if you notice on the left-hand side is a total planned expenses, right? So the budget of the project, the initial expenditure is staying very, very low over the course of the planning and design phase. And then when you start to construct, there's a lot of spending going on. And this is really not what we would call the ideal process. In the ideal process, you would engage in a lot more preparation ahead of time. So you would invest earlier in order to reduce your total project costs over the life of the construction, and then obviously the operation and maintenance of a building or a road or whatever. But there's this danger point, there's this pitfall wherein if during the early parts of the process you're not employing the right types of mechanisms and concepts, technology is part of that, but also just thinking around how stakeholders use data in a project, you could run into overages, right? Into a situation where your expenses actually accelerate and go higher than what they would have been had you stayed in the more traditional process. So we want to avoid that, right? We want to avoid that. And a way in which we can avoid that is to insert ourselves into the early part of project planning, design, conceptual planning, all of that. So surveyors and geospatial professionals, historically speaking, had not been heavily involved in that phase of a project. And so even though we were responsive when project construction and site construction started, and we would be very involved in what goes on in the field in that space, at the onset of a project, at the very start, before any ground is broken, you didn't see a heavy influence of the geospatial sciences or the geospatial professionals in there, making sure that standards were being made in a way that, you know, could be beneficial to the project's life cycle. So that includes stuff like field to office to field, all of the data sharing and how that happens, what kind of platforms are used, what types of technology are going to enable that. Also deciding standards and mechanisms in which different stakeholders in the project can access geospatial data, interpret it, whilst probably ideally keeping the people with the domain expertise, whether the surveyor or the scanning professional or the mapping professional or the engineers, kind of as the custodians of the data, but being able to share it in a way that is meaningful for all the stakeholders. And then kind of employing the idea of making sure that you have created through that process a constructible model. And the constructible model is not a very it's not a difficult term to understand, but the execution of building that up it takes some practice. And so you want to employ what we call parametric design principles into the entire planning process of a project. That means at the beginning, you know, what a lot of people do now, and as they describe as BIM, is they say, okay, well, I'm going to get a model of the building that I build, or I'm going to do an as-built check on a design that I have. But actually, through the process using parametric design principles, you end up understanding at a higher level of detail, at a much higher level of detail, all of the relational data between different geospatial data sets. So the only way to really do this in an effective way is to make sure that geospatial data, that is georeferenced information, is sort of lining up. If you think of the building not as a 3D structure, but as different layers of, say, like a 3-dimensional GIS, you end up realizing that you need control to keep all of these data sets aligned with one another. And so the constructible model enables that. There are principles around it that are making sure that all the data sets are essentially having a dialogue, right? A geospatial dialogue with one another. And the benefits of that are huge, right? There's a huge reduction in rework. You're decreasing the amount of time that people need to spend on site, let alone spend understanding what's going on site. And there's all kinds of different economic benefits to this, right? Whether or not you are, if you're a service provider in there, if you are a prime contractor, a subcontractor, or even if you're the project owner, or maybe even the government body that needs to have oversight over this whole process. So if we agree that, you know, that would be the ideal situation, well, how to enact this change? I think in our profession, there is a lot of, as Victor said, you know, there is a lot of work that needs to be done with standards and even legislation that guide the adoption of these types of principles in the construction sector, right? So that maybe is not something that, as a private surveyor or somebody working in a private company can do necessarily, but certainly there are two things we can do. One is we can stop being reactive as a business and we can start being proactive. So looking at the way in which a lot of, even here in Singapore, which is, you know, punching above its weight in terms of productivity in this space, you still have a lot of businesses in the survey community that are highly reactive to the market, waiting for business, responding to opportunities versus going out, being proactive and educating the market and being much more in a consultative capacity, going in to talk to contractors, going in to talk to even government to understand their needs and understand and to communicate what can be done with the latest technology. And then, so that's one, which is very much for the commercially minded to be much more proactive in that space, right? Become the consultant, become the person that's educating the market. We've not traditionally done that. Surveyors in particular are very conservative historically, and so have been less about preaching the gospel and more about getting it right. We kind of have to strike a new balance, I think, in order for this to really accelerate. And then make sure you're up to speed on the tech, right? Our technology space has drastically changed in a very short time. I've been in this business with Trimble. I've been working for Trimble for almost 10 years. The amount of change in what's happened in the technology during the time that I've been here, let alone our 40-year history, is huge. And so there's one thing, you know, this slide I designed to really highlight, you know, how communication and in particular the utilization of the cloud can help drive productivity in a project. You think about what's going on in the field, which is the left-hand side of the slide, which is very much our wheelhouse, right? As surveyors, we know what a GNSS rover does. We know what a total station does, what a scanning total station does, what a laser scanner does, and how they can be utilized in any given project. We know how the processing software works and how to make what we capture in the field useful for to create deliverables. But going a step further, we need to take all of that and insert that into a much more dynamic workflow wherein what we create and what we collect out of the field and those deliverables get shared immediately via the cloud with multiple stakeholders. And that then, you know, sparks additional information coming back to people that are capturing information in the field, and maybe additional information comes back into the field. If you think about the design of a project, a design file coming into the field, checking an as-built against that, and then sending that back to a group of architects or engineers that are concerned about one problem or another. You don't actually have to leave the field if you're utilizing the cloud to then go ahead and have a small amount of dialogue with that group and check additional things. And so small levels of productivity being gained using the cloud, I think initially that's certainly supported by all of the leaders in the technology development space like Trimble, but also, you know, it takes the surveyor to educate those stakeholders on what's possible for them to see so that you can really expedite the process of becoming more productive. You have to take a proactive approach of saying, this is how I can collect data in the field. This is how productive it will be. This is the type of detail I can provide you. Get ready because it's coming in your inbox and I need you to look at it and then respond in a very short amount of time. So there's these types of gains that can be made. And then the other thing is that just in the field alone, we're able to do so much more now. So this is my last, or not my last, my second to last slide, but it's just looking at, you know, in here you have some more of the traditional technologies. You have GNSS, you have a scanning total station. You also have laser scanners, right? These are all heavily in adoption already in building infrastructure construction. But you also have newer technologies coming on, like augmented reality, AR, or you have virtual reality coming in. You see the guy with the Trimble XR10, that's a HoloLens integration. And then you have kind of the merger of the two, wherein on the very right-hand side, you have augmented reality on a controller that's operating an RTK rover. And so you're merging the survey workflow with something that was a little bit less, I guess you could call it less scientific or less accurate historically, which would have been that AR piece. You're merging that with very high level accurate positioning and being able to do more in the field with that GNSS rover and that workflow. So merging the two is really critical, and understanding how that could impact and help your customers is a big thing to note. Finally, just a snapshot of where this practice is actually already underway. This is a picture out of the UK at the construction of a nuclear power plant, where the steel design is previously the model is georeferenced and then brought into the field via a VR tool, but because it's georeferenced, then you can do some checks against what was actually constructed and prefab to come onto the site. And the amount of rework and sort of heading off mistakes that would be quite costly in a high value project like this really help the bottom line. And so finally, last takeaway from my spiel here is that, focus on, even if you're a small surveying firm, like, you need to start focusing on what the impact of the types of technology you're using can have on your customer's bottom line. Typically, a survey company doesn't employ an economist to go in and analyze this stuff, but to have that mindset is going to help you compete in this space. So I would encourage you to start thinking along the lines of how the efficiency gains in the technology can really impact your customers' performance as well as yours. Thank you very much. That's all from me. Let me see if I can.
Thank you, John. Thank you very much. That was a very excellent details on how the economics versus value and the technology to the surveying comes in. I would now move to Neil to come and talk about himself a little bit and his presentation.
Thanks, Saibal. And yeah, we'll cover John. So I'll try and cover some things from one of the other manufacturers' perspectives. This is from Hexagon or Leica Geosystems. Let me just bring up the slides. I don't necessarily need to show my slides, but if you just double click on the icon or pin the slides, then you can bring it up to a bigger panel. So I won't be going the 8 minutes, Saibal, so I'll try and catch us up on some time. Hope you're happy for that. So a quick introduction of myself. So I've been in the surveying industry for nearly 34 years. With that 14 years in the civil construction, mainly building railways in tunnels. And this is what brought me to Singapore in 1996. And then about the last 20 years as a measurement specialist with Leica Geosystems, doing many activities. Recently, I've been looking at more the regional technical support of all our products, all our total stations and laser scanners, GNSS sensors. So I thought I'd bring up some of this slide here. These are some of the innovation that's happened. So I use some of these products. Up on the top left, there's some TC1000s, and in the middle, there's some T2s and T16s. There's a T3 there. So I actually used these in the late 80s and early 90s. So where we are now with the innovation, it's gone tremendously. So the last 34 years, there's so much innovation been going on. Where we are from Leica Geosystems, this is really what excited me to get into working for Leica Geosystems. Certainly the technology and the innovation that's going on with the company. So starting back in the 90s, I was using some of those old optical mechanical instruments, and then I was introduced to some of the innovation that was going on through EDMs, automatic target recognition, the GNSS, even the laser scanners. So laser scanners started coming out in the late 1999, year 2000. So I could see where the industry was going, and it was very, very exciting to be asked to come and join the manufacturer to represent the surveying profession around the region. So what is certainly a trend is this. So even back then, when I was practicing a surveyor, the content was always in some sort of form of a digital form, but it was always printed out into a paper form. So we were creating digital worlds, generally a 2D world. This has changed so much in the last probably 10, 15 years. It's now becoming 3D, and we've all heard about the BIM, and we're talking about the digital world. To be brought into an accessible platform. So these accessible platforms, as John was talking about, we're looking at VR and AR, but the user still demands very, very high accuracy. And this is, I think, where the products, the measurement sensors are really starting to ensure we still get into the same quality of measurement accuracy, irrespective of actually who is using these products nowadays. So these are some of the more innovative sensors that have been on the market now for the last 5-6 years. So we're certainly seeing a big trend in laser scanners. So it's not just about the laser scanner. We're calling it like a reality capture now. So we are really capturing the as is, the field representation to make a digital twin. So the reality capture type sensors are really quite innovative recently, because not just on the sensor, it's actually the workflow that the field capture is just really just the push of the button. It takes it into the software. The software is auto-aligning these many point clouds, and then we can deliver it, publish the point cloud for consumption into platforms like AutoCAD and Bentley, PDMS, and many of the CAD packages. So on the left, we have we're looking at small mobile mapping sensors, the BLK2Go. This is quite a recent innovation from Leica Geosystems. This is a small handheld laser scanner that allows an individual to just press the button and start walking around the site, and he's collecting laser scanner plus imagery as he goes. This is then processed in the various software and then published, and as I say, moves it on into the digital platforms. We've also got some new innovative total stations. So when we're looking at design data, we did mention about the BIM, the building information modeling. Having the design uploaded onto total stations, we can now not use paper plans, we're using digital plans onto the total station. So we can assure that we're actually setting out the right thing in the right place first time. It's a big problem on a lot of construction sites that the features are built in the wrong place and they need to be taken down, cut back, hacked out, and then rebuilt again. And that's a big cost implication by having to rework things as well. And then only about 2 weeks ago, we brought out one of our new GNSS sensors, GNSS sensors with an imaging capability. So this is also very simple to use. You just press a start and a stop button. So the user will go out and capture areas where he can't access, certainly in trenches or in areas of very difficult to access. He can just walk past using a GNSS sensor, collect lots and lots of images, stitch the images together, and create point clouds, and then deliver them to the end users. So really, that's kind of it. But I've got a few thoughts or something. I've got probably a few more minutes to talk about. When Saibal's asking us to put some of our thoughts on the plan, finance, design, build, and the manage process, the geospatial expert is touching all of these components. One of the concerns, though, probably I do have is the technology, because it's becoming so endemic, so easy to use. I wouldn't say the reliability, it's the positional accuracy of the data sets. Are they aligned in the appropriate manner? Especially when you're looking at different disciplines, when you're looking at the architectural, the structural, the mechanical, the other types of disciplines on a construction site. Are all these features aligned in the correct manner? So having a geospatial expert on site to make sure that your data sets are fully aligned. I don't necessarily think the geospatial engineer or the surveyor is actually going to be doing the capture, but he needs to be on site to ensure that the data sets are fully aligned. When I was thinking about the finance side, you know, if we can build construction projects or ensure that the build is correct, it's built right first time, we know there's a lot of overrun costs to do with their reworks. So maybe 10, 15%, maybe not 15%, 5 to 10% of the costs are attributed to building things in the wrong place. And then you end up getting project delays and cost overruns. Then I suppose another part of the project is the ongoing operational management of the construction project. You know, when you hand over the construction drawings, the design drawings, the building might last another 50 or 60 years. So the operational lifespan of the building needs to be maintained. So when you deliver a building, you also deliver your full BIM model, so you know exactly where all your pipes are, all your hidden utilities are within the building. So that will improve the operation size of the building. There we go. I think that's it for me. So we're getting us back on time. I'll pass back to Saibal now.
Thank you, Neil. Very generous. I will pass to introduce himself, Professor Chon, and again talk about 7 to 8 minutes about the new innovations from the perspective of ISL. And what's going on in the industry and what is the future for the next 5 to 6 years time, maybe.
Thanks, Saibal, and good afternoon, everyone. And thanks to the organizing team for inviting me to join this panel. Yeah, it's really exciting to have a chance to exchange our idea and also discuss among the experts in this field. And yeah, a little bit of self-introductions about myself. I got a bachelor and master degree in surveying from Chulalongkorn University and PhD in also GNS surveying from University of New South Wales, early 2002. I have been teaching at Department of Survey Engineering, Chulalongkorn University for more than 25 years up to now. Yeah, and I'm now a full professor here and act as a head of Department of Survey Engineering. To save time from sharing my idea, because we have 3 previous speakers talking about a good example that they have been implementing in Singapore, like Victor already mentioned. And also we see a lot of innovations from our industry partners from Trimble and Leica, presented by John and also Neil. They are really interesting things, but to keep this short so that we can move forward to other point or other question or any discussion, because I'm the only one in this panel that come from university, I would like to share my personal opinion and observation with you on how we adjust ourselves, not only from the COVID-19 pandemic, but also the rapid change of technology that related to geospatial community. Of course, we observe a big impact from the COVID-19. When we look at the bad thing, yeah, it affects a lot of things and a lot of human activities around the world. But I would like to point out the good things on this as an advantage. The advantage of this is being that we have to try our best to explore to the new technologies and even force ourselves to learn and adjust to the new thing. So I can say that the COVID-19 does help accelerating the use and implementation of new technology and innovations, especially in geospatial fields. So my keyword on this is being pointed out as an adaptation. People need to adapt themselves to the new things, like other sectors. Another good thing is that the students, in my point of view, and the young generation people can observe that the geospatial can be applied to many real-world applications, because they can see a lot of good examples. If we look at the many countries in Southeast Asia region, what they are doing, one certain thing I can say is that many geospatial infrastructures have been established during the past 5 or 10 years in this region. So this is another keyword from adaptation, is more on the infrastructure setting up. I think we can easily get more students to study and work in the geospatial field, since students can see a lot of real-world examples and application. They understand the need in the future, because most of the human activity are somehow related to the positioning data. The more precise positioning data, the more application will be used in the near future. So students can see a lot of real-world example, then they understand the geospatial field well enough, and this is confirmed by the data from or example at our university. I can give you one of example in our department, because myself is from the Department of Survey Engineering. In the past, student has a negative view about studying survey engineering, because they understand that if they want to study in this subject, they have to do a lot of work in the field, and it's not desirable for the student. So in the past, we hardly get any female students to study in our department, but now things have changed. More students show their interest in the course offered by our departments. The number of female students has also increased dramatically during the past 5 years. So in summary, I'm not very worried about promoting the geospatial to the young generations. They can understand it well and show their interest in joining this community, because they can see the trends and the use of new geospatial technologies in their real life. So try to wrap up, what I'm trying to say is that we have two keywords from the geospatial community. The first one being adaptation. So we have to adapt to the fast moving technology. And the second one is we have to prepare a good infrastructure to support the future application, like what Singapore already have. But I believe many other countries in Southeast Asia region still are lacking of this kind of infrastructure. I will come back to elaborate more on what the meaning of infrastructure I'm saying. Thanks.
Thank you, Professor Sean. That was interesting indeed. So what I now request all the other speakers to switch on their microphone and the video for us to start our panel discussion. And if everyone is ready, just let me know. I could kickstart with, I will probably use more random sequence here. However, what I'd like to do is, we had individual speakers coming in and talking about their area. I like to go back a little bit of broad discussion about what is going to happen to the industry. As I started saying that the digitalization and again, the what's called digitization process has started sometimes in 2015, 2016. The pandemic has actually kind of accelerated, as everybody knows. But what is interesting that I want to talk about is before the pandemic started, there was an article by McKinsey was saying that the industry is already losing around $1.6 trillion a year because of the various problems that we have. It is a most fragmented industry. The productivity is less than 1% for the last 20 years. And yet it is the largest industry sector of $13 trillion. So I think it is really ripe for that transformation. And I like to actually add in saying that a lot of, I mean, for me personally, and probably I know Dr. Khoo also, we believe that GeoBIM and digital twin and around that all the application that it will integrate around it could actually be sort of panacea to help that productivity problem solved. And also with the pandemic that, you know, the commercial space have to go through, there will be a lot of regeneration will go on in major cities. Do we have basically a monocentric cities, or we will have a polycentric cities? If they're polycentric cities, how does it impact, and where does the geospatial technology come in to actually accelerate that and create new jobs, new productivity, and etc. So that's how I will basically go. To start my question for probably 1 minute each for each from the panelists, we go around, starting with Dr. Khoo. I like to ask Dr. Khoo that what do you think are the most significant changes that we will go through, assuming the trajectory of technology, it will stay, in terms of customer demand, market changes like the demand changes? And also, do you think that the current industry, which is very much a project base, would turn into a product base, for example? And if that has to happen, what are the new technologies should come in to support that to happen? Please.
Yeah. So we, in Singapore's context, I think we have started quite early, you know, way back in 2010, 2010, and the realization of what digitalization can do to the industry, you know, is very strong since then, at least from the agency's perspective. And I think we need to work with the private sector to push this to implementation, right? And we all know that it's not going to be an easy task because a lot of practices has been around for very long. Cost of manpower is another area. So where is the cost benefit of digital transformation or digitalization in this area? And there comes the pandemic, and I think the pandemic actually increased the realization. You know, everyone start to really know that you know, we have to depend more on the digital technology, the digital workflow, to transform forward. We can't in industry, we can't just rely on sheer manpower to do the work, right? And also, I think together with the technology provider like Trimble and Leica, I think this must be a whole movement where you have the technology, the hardware, the software, and all these must come together with the government's policy, with the push, both from, you know, larger company to start off with, together with the governments creating standards, creating new specification, creating new guidelines, and this will be a good time, you know, for us to move this, and you need the whole community to work together. I think that's my comment.
Okay, good.
For now.
So Victor, what you're saying is we will have new opportunities will open up in the areas of new innovation, and create new efficiencies and bridge the gap and the productivity gap we have. Now, Dr. Chon, I like to ask you, now that this is what we needed, I mean, there will be demand for new innovation, new opportunities. Do you think India, the IHLs, those are equipped, are they aware of it? My personal experience is we're talking about digitalization, but nobody even started digitization. So that's the basic thing. So, Dr. Chon, what do you see around in Southeast Asian perspective? Not just the Thailand.
Yeah, I'm not very worried about the trend and technology. It's already there, the hardware and the software. My role is to prepare the people to be ready for the industry. That would be the big problem, because we are, for example, in my department and even other countries, we still have not enough surveying professional to work on this kind of thing. Because in order to make use of such technology accurately and also do something professionally, we need some kind of professional surveyor in order to use their hardware product. So the problem is we have to find a way to make students aware of the change of technology and be able to adapt to the new technology very quickly. It's not going to be relying on only one sensors, but could be other kind of sensor that building up the system. So I would confirm with the Victor's answer that more and more work is going to be available for the geospatial community. It's just about how we can attract more people and make these people become a professional one, to have a judgment to use the right tools, right hardware and procedure to collect the data. And of course, the need for the future is getting more and more precise positioning data, not only for the map or mapping, but also the positioning data for the application is also quite crucial.
So, Professor Chon, what you're saying is the capacity, you worry about the capacity, and the capacity has to come either from the government side, or not either or, but it's from the government, from the universities, and also the private sector. So I would like to invite Neil to say, do you think that capacity, if given the capacity is the issue for the new technology, how do you think the private sector is actually, is it ready? What do you think, or there is a huge gap in the private sector innovation itself to supply those talents and technology both?
Yeah, thanks, Saibal. It's probably quite clear that the product at the product level, at the measurement center level, the innovation is going on rapidly. So I think the access to measurement sensors by industry is becoming so transparent to users. Now I think once we look at the collection of the data, of the measurement data, we've got to make sure it's aligned properly. And this is where our geospatial experts come in. And we need to feed these geospatial experts into the academic world so they get trained formally in the correct way. But I think we also need the legislation side. We need to have the likes of, well, BCI have been doing a great job in the last probably 2-3 years before the pandemic was happening. So they need to create that framework for these spatial experts to thrive. And then the private companies that want to adopt this technology, but sometimes they're limited by the current frameworks.
So Neil, John, I like to invite you. What I'm trying to say now, I'm talking after talking to Dr. Khoo and Professor Chan and Neil. Seems that yes, we have the intent, we have the technology, we have the capacity, everything is there. Why do we still think the process of digitalization outside of Singapore, okay, and maybe Sydney and Melbourne and New York is so slow? People have not even started what Singapore started probably in 2010. Why you think if everything is there, what's the delay? What's the problem? Why we are still losing that much on productivity, and why we still working with the old arcane ways?
Well, I have two I have three thoughts on that. Two are the first are corresponding infrastructures that support it. So Singapore has done a lot of trial and error, right? The Japanese have done a lot of trial and error. China has done a lot of trial and error. Where you have 5G and where you have cloud computing being adopted quickly, you will start to get that optimization. The problem is right now is that you have a lot of development going into what's happening in the field, but the mechanism by which to move that into a more user ubiquitous space, right, where it can be leveraged by all the different stakeholders in a construction project is not there. It's actually still quite mechanical or bespoke to try to get something that you've created in the field or collected in the field into the hands of the people that need it, dilute it down to the level that they need it, and then, you know, if you're a geospatial professional, you know all of the intricacies of what you've created. None of that really matters in the context of somebody who's looking at it outside the discipline. And so the reason why I think 5G and cloud computing are going to accelerate that is because it's not our technology to develop necessarily, but once it's available, it will speed up the ability to move data in a more meaningful way faster, and therefore getting it into the hands of the people that right now our own industry's technology actually allows for, but we're limited by the infrastructure that we need to move it from place to place, right? So if you think of like a 3D laser scan, everybody has 3D laser scanners now, but actually making sense of that data in a meaningful way is difficult to do still because of communications infrastructure not supporting it. So those are two things. And then the third thought is that in countries, especially where you have the government having a heavier hand in things like public utilities, any sort of public service provision, you will have a more accelerated adoption of these tools. Because more and more as countries compete, you know, the governments that are invested in that type of public service provision will be incentivized to treat as much of what they control in a more optimal way. Cost savings and basically not necessarily profitability in the company sense, but cost savings from an operational standpoint will drive that as well. So you see that in places where you kind of have a quasi public run but you don't see that in places where everything is completely privatized. So yeah, those are two thoughts I have. I mean, I think the industry is, as Dr. Chon said, like the industry is ready to move forward, at least from the technology standpoint, and then the legislative and then the corresponding infrastructure to support. I think those are the two components that are kind of holding back. There are areas where it's already happening, right? There are areas where it's already happening, but it's not at the level of ubiquity that you want to see it to really make an impact.
So we have 2 more minutes, so I will have a conclusion remark go back to Dr. Khoo. I mean, talking to all of you, it seems that Singapore is probably the most ready country when we talk about geospatial technologies, data modeling, parametric modeling, GeoBIM, and other related technologies. So one area from the economics and jobs perspective for Singapore, I think the Singapore companies should be actually helping and grabbing projects outside of Singapore. It could be Europe, it could be Asia, it could be anywhere else. Now, do you think for that to happen, there should be enough demand situation? That means you're talking about countries in ASEAN, countries in APEC, and countries even in Europe. How do you think, Victor, that I think the Singapore industry, the startups and the next layer and the big guns like SLA, Urbana and all should line up together, okay, and to actually grab these opportunities that over the next 2 to 3 years, that all these cities will start digitizing and digitalizing?
So from the agency's perspective, I think what we hope is that we will start from home. So in Singapore, locally, we put this in place. The companies are able to to meet our requirement, the way we look at our workflow, the digital workflow. These are all very good starting point, and hopefully when other countries come on board, I think these companies are able to venture out. So we try to focus on getting our infrastructure. I think the keyword that Professor Chong mentioned, infrastructure is a key foundation to a lot of this digitalization transformation, and that is not built overnight. That is built over a long vision. We have to start with the different components. So even as of today, I still believe that it is still a journey, it's still a beginning of a journey for us, and for many countries. It really depends on where you are, where you come from, and where you are. Now, no one can say that we are there in terms of our digital journey, and there's a lot more to be done, and hopefully with what the government is doing, looking at standards, framework, and everything, that will trigger down through the industry and through the sector, and that will help the Singapore local companies to move out from Singapore. Thank you.
All right, I think we come to an end of this great session. I hope I enjoyed it myself, and hope all of you have enjoyed it. And off on to Vanessa.
Thank you very much, Saibal and speakers for the panel. Please do join us for 2 more webinars after this. We have the Autodesk webinar coming up at 5 to 5:30, and Amazon Web Services. See you then. Thank you.
Bye-bye.
Thank you.